Okay, today we are continuing with those exponent properties, and we need to evaluate these without a calculator. So everything today is without a calculator. Number one, this is just a good old 7th grade, 8th grade problem. We have negative 1 to the 12th power. So notice if the negative is in parentheses, that means the negative is repeated 12 times. That would be negative 1 times negative 1 times negative 1, 12 times. If I have an even number of negatives, would my answer be positive or negative? Positive. Positive. So what's the answer for number 1? Positive 1 is the answer. Number 2, we have negative 3 to the 4th power. This time, is that negative in parentheses?
No.
No, so that means the negative is not repeated. So this essentially is the same as just negative 1 times 3 to the 4th. So it's 3, that's the base. So if I simplify that, what is 3 to the 4th power? 81. So this is just negative 1 times 81, so what's the answer?
Negative 81.
Negative 81. So there, the negative is not repeated because the negative is not included with the base. Next one, number 3, we talked about this on Friday. I have a fraction to a negative power. How do I simplify that?
Flip it. Block.
Flip it. So 2/3, flip it, it becomes 3/2. And negative 3 changes to positive 3. Now everything in that fraction needs to be cubed. So what is 3 cubed? 27. And what is 2 cubed? 8. Leave your answer as an improper fraction. Don't convert to a mixed number. And we'll go through these pretty quickly. Number 4. 5 to the 0 power is 1. That's something you need to memorize. The number to the 0 power is 1. Number 5. We have 5 times 5 squared. When the bases are the same, keep the same base. And what do I do with these exponents? Add them. So 1 plus 2 is 3. And what is 5 cubed? 125 is our answer. Problem number 6. Now, remember, this is without a calculator. So do I want to find 8 to the 3rd power? Or do I want to find 64 to the 1st power and then multiply that by 16 squared? No. Since this is without a calculator, there has to be a simpler way to answer that question. And what would be the simpler way?
Finding a common factor.
Yeah, and we need to get a common base. So looking at our values, we have 8, 64, and 16. What would be the common base there?
2.
2. So instead of 8, that would be 2 cubed. And then 8 is raised to the 3rd power. And instead of 64, that would be 2 to what power? 2 to the 6th power. And 64 is raised to the negative 1 power. And in the denominator, 16 would be 2 to what power? 2 to the 4th power. And 16 is squared. Now, power to a power, what do I do with these exponents? Multiply. So 3 times 3 is
9.
So that gives us 2 to the 9. Times power to a power multiply. And 6 times negative 1? Negative 6. And down here, 4 times 2 is 8. Now it got a whole lot simpler. Now I still need to simplify within the numerator. And when I'm multiplying and the bases are the same, what do I do with those exponents? Add them. So it's 9 plus negative 6. 3. And then in the denominator we have 2 to the 8. And where's the bigger exponent, top or bottom? Bottom. So my answer goes in the bottom, and 8 minus 3 is 5. So 2 to the 5th in the bottom, and what goes at the top?
1.
A 1. And my final answer would be what?
1/32.
1/32. So 1 over 32. So instead of trying to multiply and getting a big answer, just try to find a common base to keep things simple. Okay, now it says use the laws of exponents to simplify. So number 7, what are we doing with those two expressions? Multiplying. So what's 3 times 4? And when we're multiplying and the bases are the same, what do we do with the exponent? Add them, so for the a's, this would be 1 plus 2, which is 3. So 12a cubed is the answer. Number 8, the first thing you need to do is you need to simplify the fraction up front. So 27 and 45 have a common factor of what? 9. So what's 27 divided by 9? 3. And what's 45 divided by 9? 5. Now when we're dividing, look for the bigger one, for the a's. Where's the bigger a, top or bottom? For our answer for a goes on the bottom. And we only have one b, so that b cubed is going to stay in the top. And where's the bigger c? Top. Now, when you're dividing and the bases are the same, what do we do with those exponents? Subtract them. So for the a's, 4 minus 3 is what? 1. Do I really have to put a to the first? No. And then for the c's, what's 5 minus 2? 3. Number 9. What is number 9 called? Power to a power. So everything in the parentheses needs to be cubed. So negative 3, if the negative's in parentheses, that means it's repeated. So negative 3 cubed means negative 3 times negative 3 times negative 3. And what does that give us? Negative 27. And the x needs to be cubed. And y squared, when you cube it, power to a power, what do we do with those exponents? Multiply, and 2 times 3 is 6. So negative 27, x cubed, y to the 6. Number 10, when you're multiplying and the bases are the same, what do you do with those exponents? Add them. So we need to add x plus 3 with x minus 3. What happens with the 3's? They cancel. And what's x plus x? 2x. So the answer is a to the 2x power. Number 11. What's wrong with 11? Has negative exponent. So let's move negative exponent. So x to the negative 2 goes to the bottom, becomes x to the positive 2. X to the negative 3 goes to the top, becomes x to the positive 3. Y cubed is good because it's positive. Y squared is good because it's positive. Z to the negative 1 goes to the bottom, becomes z to the positive 1. So once you've moved all of your negative exponents, you're going to make things a lot simpler for you. And when you're dividing, look for the bigger one. So for the x's, where's the bigger x? Top. So our answer for x goes in the top. Where's the bigger y? Top. And we only have one z, so it's going to stay in the denominator. And when I'm dividing and the bases are the same, what do we do with those exponents? Subtract them. So for the x's, what's 3 minus 2? 1. And for the y's, what's 3 minus 2? 1. There's our answer, xy over z. Now number 12. How would we do number 12? We need to, well, if I simplify what's in the parentheses, I could do that, but here, what do you do if you have something in front of parentheses? Distribute. So let's just distribute with a negative. So 3 times 2 would give us 6. And then we'd have x to the negative 2, y to the negative 3. Distributing again, 3 times 1 is 3. And then we'll have our x. And y to the negative 3 times y to the first. When you're multiplying, what do you do with those exponents? Add them, so it's negative 3 plus 1. Negative 2. And do it one more time. 3 times 1 is 3. And y to the negative 3 times y to the 2, we add those, and negative 3 plus 2 would be negative 1. Can I leave my answer like that?
No.
No. So after you distribute, go ahead and take care of those negative exponents. So this would be 6, and what goes to the bottom? X squared, y cubed. And 3x stays on the top. y squared goes to the bottom, 3 stays up top, y goes to the bottom. Can I add those? Are they like terms? No. In order to add them, I would have to get a common denominator. We're not going to go that far. We'll say that's our final answer. Okay, number 13, we have several things going on here. The first thing I would probably do is take care of my negative exponent. So for this first term, what stays at the top? 4x cubed. What goes to the bottom? Y to the 6. And inside the parentheses, what stays at the top? Y squared. What goes to the bottom? X. And this fraction is to a negative exponent. So if you have a fraction to a negative power, what do? Flip it. So we'll leave this first one alone, 4x cubed over y to the 6. Flipping the fraction, the x goes to the top, y squared goes to the bottom. And after you flip it, the negative 3 changes to positive 3. Now, everything in the parentheses needs to be cubed. So let's go ahead and cube it. So x, when you cube it, gives you x cubed. And y squared, when you cube it, power to a power, what do we do with those exponents? Multiply. What's 2 times 3? 6. Can I add those? Yes, they have a common denominator, so keep the common denominator. And when you add those numerators, what does that give you? 4x cubed plus 1x cubed would give us 5x cubed. So 5x cubed over y to the 6. And number 14. What do you think I should do with 14? Take care of those negative exponents. So instead of x to the negative 2, how could I rewrite that? X to the negative 2.
X squared on the bottom.
Yeah, 1 over x squared. So we have minus x squared. And instead of x to the negative 1, how would I rewrite that? 1 over x. Minus x. Now, I can't leave it as a compound fraction, so I can't have a fraction over a fraction. So the next thing we'll have to do is we'll need to clear out those fractions. So if you have more than one denominator, look at both denominators. So we have an x squared and an x. So what can I multiply by to cancel out the denominator? Well, if I just do x, would that cancel out the x squared?
No.
Well, if you have 2 and they're the same variable, it has to be the higher power. So we need to distribute x squared to both the numerator and the denominator. So whenever you multiply the top by, you have to do the same thing to the bottom so that your expression remains equivalent. So whatever you do to the top, you have to do to the bottom. So when I distribute this x squared, what's x squared times 1 over x squared? 1. And what's x squared times negative x squared?
Negative x to the 4.
Negative x to the 4th. And what's x squared times 1 over x? X. And what's x squared times negative x? Negative x cubed. Now, after you've done that, do you notice anything? What is this called right here? Difference of squares. So let's do some factor and see if anything cancels for us. So if I factor that as a difference of squares, it would be 1 minus x squared, 1 plus x squared. And how would I factor that denominator? Yeah, if you notice, both of these have an x in common, so we factor out the GCF. And when you factor out the x, we're going to have 1 minus x squared. So after factoring, does anything cancel? 1 minus x squared on top, 1 minus x squared on bottom. So our answer, if I write it in standard form instead of 1 plus x squared, I make this x squared plus 1 over x. Now, can I cancel the x squared and x?
No.
No, because this is part of the binomial, this is part of the monomial. You can't do that. Okay, number 15 is going to be kind of similar to number 14. So what's the first thing you think we should do? Yeah, the first thing we need to do is get rid of those negative exponents. So I need to rewrite them. So this will be 1 minus, and x goes to the top, y to the first goes to the bottom. How do I rewrite y to the negative 1?
1 over y.
1 over y. Minus, and how do I rewrite x to the negative 1?
1 over x.
1 over x. Now you can't leave it as a compound fraction, so you can't have a fraction over a fraction. So you'll have to clear out the denominator. So notice we have a y, and an x. So what would be a common denominator? xy. So whenever you multiply the top by, you also have to multiply the bottom by. So distribute your xy. So what's xy times 1? xy. So we'll have our minus. And what's xy times x over y? The y's will cancel. And then x times x will give us x squared. Now distributing in the denominator, what's xy times 1 over y?
1.
The y's cancel, so it's just x. And for the last one, what's xy times 1 over x? Y. After that, the next thing you need to see is you need to see if you can factor anything. So can we factor either one of those? The top. How would I factor the top? Yeah, there's a GCF, so factor out the x. And when we factor out the x, what goes in the parentheses? Y minus x. Now, technically, are these the same?
No.
Let me put in some numbers for you. What if I have 7 minus 2 and 2 minus 7? What's 7 minus 2? 5. What's 2 minus 7? Negative 5. So are these the same? No, but they do cancel as a factor of what? Negative 1. Because what's 5 divided by negative 5? Negative 1. So x times negative 1, what's our final answer? Negative x. Okay, on the back. The first thing I would do is work inside the parentheses. So how would I rewrite a to the negative 1 power?
1 over
1 over a. And how would I rewrite b to the negative 1?
1 over b.
1 over b. Can I add those fractions together? No. What do I have to have? Common denominator. What would that common denominator be? AB. AB for the common denominator. So what would I have in the numerator?
1. B.
B. And the other one? A. Now I can add them together. Instead of b plus a, I'm going to write it as a plus b over ab to the negative 1. Now leave my answer like that? No. If I have a fraction to a negative power, what do? Flip it. So ab goes to the top, plus b goes to the bottom, and so negative 1, what does it change to? Positive 1. So it's just AB over A plus B. Number 17. What is this called right here?
Power to power.
Power to a power. So this power to a power, what do I do with those exponents?
Multiply.
Multiply. So what is 3/2 times 1/2? 3, 4. Now for the rational exponent, what is the base there? 16. What root are we taking? 4th root. Remember that bottom number is the root. And what power do we raise it to?
3.
The third. So if you have a rational exponent, convert to radical form. Now what's the 4th root of 16?
2.
And what's 2 cubed?
8.
8.
And number 18? What is the base for number 18? 27. Notice this is actually negative 1 times 27 to the 2/3. If the base were negative, then it would have looked like this. So if the base was negative, it would be included in the parentheses, but it's not. So this just means negative 1 times 27 to the 2/3. So this would be negative 1. If you have a rational exponent, convert to radical form. So what is our base? 27. What root are we taking? The cube root. And what power do we raise it to? Square. So this would be negative 1 times, what's the cube root of 27? 3, and what's 3 squared? 9, and when we multiply these, what do we get? Negative 9. Hey, I want you to do number 19. And 20. And 21. Number 21, it will be imaginary. Yes, do the next three. 19, 20, and 21. And 21 will be imaginary. No, you're taking the Okay, number 19. What is the base this time?
Negative 27.
This time the base is negative 27. What root are we taking? Cube root. And what power do we raise it to? Square. What's the cube root of negative 27? First of all, can you take the cube root of a negative?
Yes.
Yes, you can. So the cube root of negative 27 would be negative 3, because negative 3 times negative 3 times negative 3 gives you negative 27. So that would be negative 3 squared, which is what? 9. And number 20, what is the base?
27.
27. What root are we taking?
Cube.
Cube root. And what power do we raise it to? Negative 2. So what's the cube root of 27?
3.
3. And 3 to the negative 2? 1/9. 3 to the negative 2 is 1/9. number 21, what is the base? -4, what root are we taking? Square root, and what power do we raise it to? Cube to the third. Now for -4, this is really -1 times 4. And what's the square root of -1? I. Square root of 4 is 2, so this is just 2i cubed. So both of these need to be cubed. So 2 cubed is 8, and then the I is also cubed. But that's not the final answer, because I can break up I cubed. I can break that up into I squared times I, right? I squared times I is I cubed. And what is I squared equal to? -1. And when you multiply those, what's the final answer? -8i. That's a good old algebra 2 problem. -8i. Okay, the last section. It says to express the simplest form using positive rational exponents. So notice we have to have positive rational exponents. So we're not simplifying, we're just converting from radical form to rational exponent form. So looking at number 22. The first thing I would do is get rid of the negative exponents inside that right hand. So we'll have the 8 and the b squared up top, and a to the -1 goes to the bottom, becomes a to the positive 1. So notice the first part of this answer says there has to be positive exponents. So now everything's positive, right? So I took care of that. Now I need to convert from radical form to the exponential form. So looking at that radical form, what was the base? A b squared over a. What power was it raised to?
2/6.
The power is 2, and the root is 6. Technically, is that in simplest form? No, because 2, 6, what does that simplify to?
1/3.
1/3. So now, is my answer with positive rational exponents?
Yes.
Yes. So that's the answer. We're not doing anything else. We're just rewriting it with a positive rational exponent. So that's all we can do there. Next one, number 23. Now, again, we have to have rational exponents. Do you see any exponents? No. So all of these we need to convert to exponential form. So instead of square root of x, I could rewrite that as x to what power? 1/2. And instead of the cube root of x, I could rewrite that as x to what power? 1/3. Instead of the fifth root of x, I could rewrite that as x to the 1/5. Now when I'm multiplying, the bases are the same. What do I do with those exponents? Add them. Can I add those fractions? We have to have a common denominator in order to add fractions. So what would be the common denominator between 2, 3, and 5? 30. So instead of 1/2, that would be 15/30. Instead of 1/3, that would be 10/30. Instead of 1/5, that would be 6/30. I forgot the x, so there it is. And now I can go ahead and add those exponents, so yeah, that would be 31/30. So is my answer with a positive rational exponent? Yes. So that's our answer, x to the 31/30. And then number 24. We're going to have to distribute here. So this is 3 times 1 is 3. And for the x's, when you're multiplying, what do you do with the exponent? Add them, so it's negative 1/3 plus 1/3.
0.
0. Distribute again. What's 3 times negative 4? Negative 12. And for the x's, add the exponent, so it's negative 1/3 plus 4/3. 3/3, which is 1. Is that my answer?
You don't even need to have the one with the exponent.
I don't have to have the 1 for the exponent, that's correct.
You don't have to have 2x to be 0 either, because it's 1.
Yeah, I need the 3, but what is x to the 0 power?
1.
1. So this answer would just be 3 minus 12x. Technically, you could leave it like that, but is it in standard form?
No. 12x. Negative 12x.
Negative 12x plus 3 for standard form. And the last one, number 25, last but not least, this one. Now, what if I did this? What if I put this over 1?
Flip it.
I could flip it, right? So if I flipped it, what would go to the top? 1, what would go to the bottom? Everything else. 16, A to the 4/3, B to the 1/2, and that negative 1/2 was to become positive 1/2. Is my answer with a positive rational exponent? Yes, so technically, we're finished.